Chapter 2, Number 43. Starting from rest, a boat increases its speed to 4.82 meters per second with a constant acceleration. A. What is the boat's average speed? And B. If it takes the boat 4.77 seconds to reach the speed, how far has it traveled? And I think I'm going to solve this actually through multiple ways of doing it. So the first way that occurs to me is, as always, we draw a sketch. So this is our boat. And then the boat accelerates over. So the boat was at rest. It has some acceleration going this way, which I don't know, it wasn't given to us. And it has some final velocity, which is 4.82 meters per second. And we know that it had times which were t equals 0 here, and t equals 4.77 seconds at the end. So to get part A, we can do a bunch of things. The shortest way probably is to recognize that if the acceleration is constant, then the average speed is the same as the mean speed. And in fact here that's even easier because we started off with 0 velocity at the start and we end at 4.82 meters per second. So we take the mean of those two numbers and we get just 2.41 meters per second. And then part B is pretty easy because then we can say, oh, but we also know that the average velocity is delta x over delta t, which implies that delta x is v average delta t, so it's 2.41 meters per second times the 4.77 seconds. This is 11.4957 meters per second, and then we say that we have really 3 digits of accuracy, since we have 3 digits, 3 sig figs in both numbers, so we should round this to being 11.5 meters per second. Okay, so that was relatively straightforward. I sort of want to approach this a different way and show you an alternate way of doing it using a different equation, only because in physics there's often many ways to do it, and it's useful to be able to see it many different ways. But if you're okay with what we've done here, then you're okay, and the rest of this is optional. All right, so here is our problem again with a slightly revised sketch, but nothing really changed in it. And I'm going to approach this backward and do part B first, and then get part A, which will be almost trivial. To get part B first, I really need to find the acceleration. So I'm going to take the equation that v equals v0 plus at, and I'm going to solve that for a. And I'm going to get that the acceleration is v minus v0 all over t. So in this case, it's 4.82 meters per second minus 0 meters per second over 4.77 seconds, which comes out to be 1.0104 meters per second squared, which I'm going to carry as, well, I'll carry in those digits and I'll round at the end because I'm not really done. Instead, I'm now going to go and I'm going to say, what can I do with that to get position data? And I can say that we have this equation, x equals x0 plus v0t plus a half at squared, and conveniently enough, that's 0 and that's 0. So I really end up with just 1/2 at squared, or 1/2 of the thing I just found, times the 4.77 seconds all squared. And that turns out to be 11.49476 whatever meters, which again we can say we have only 3 digits, and so we get the same 11.5. And you'd be figuring for saying, well, duh, then that was what we have. But what we've gotten is we've got that a different way. And having done that, then almost in a silly manner, I can go back up here and I can say, I'm just going to carve it out here so it's in one place, that I can do part A. And I can say, okay, well then the average velocity is defined as the change in position over the change in time, or the 11.5 meters over the 4.77 seconds, which is 2.41 meters per second, which again agrees with what we had in the first way we solved it. This is definitely a bit more roundabout and less obvious probably, but it does mean that you can go through any method that you see, especially in kinematics. There's usually 3 independent ways of going, or maybe quasi-independent, but 3 ways that you can approach a problem. You should feel free always to solve it in whatever order occurs to you. Just because Walker put A and then B doesn't mean you have to solve it A and then B.